So in my last video I used my multimeter that can measure capacitance to measure the capacitance of these three capacitors in series plus their voltages and stuff. I'm not going to go too much into that in this video. In this video I'm going to use the LCR meter to measure the inductors in series. And now I'm going to take the test leads from that multimeter that I used, plug them into here, and you notice when I plug in the test leads we already have a little capacitance coming up. That's the main thing this meter notices now. There's some capacitance being measured. That's actually the capacitance of the wires here. The closer I get the wires to each other, the more you see the capacitance goes up. Now this is in picofarads. These capacitors are in microfarads. So microfarads are a lot larger unit, so that small amount of capacitance the wire won't really matter. So you can see it measures to about 50 microfarads. This is rated to be 47 microfarads, but capacitors are usually slightly off. Now when we measure two in series, these are equal value. They're both rated for 47 microfarads, but they're both measuring about 50 microfarads. But you see when we measure them in series, it's about half, about 25 microfarads, half of 50. Now when we measure three of them in series, now it's about a third of 50 microfarads. Again, this is also rated to be 47 microfarads, and you can see it's about 50 microfarads. So in any case, that's capacitors in series. Now these inductors are also in series. And so with inductors, instead of the inductance going down in series, here you can see one inductor is 11, now that's millihenry, mH. They're rated to be 10 millihenries, so they're slightly above. When I measure these two, you see it almost doubled, didn't quite double. I'm not sure why, because when I measure this inductor directly, you see it's also 11 millihenry. But it almost doubled. And when we measure three, now you see we more than tripled, or we about tripled the inductance. So with the three, it shows up. I don't know why with two it doesn't quite double, but it's close. But you can clearly see the inductance goes up when inductors are in series. Now I'm going to take the capacitors and put two in parallel. So I'm going to wire them both into the same rows there, and I'm going to do the same thing with two inductors. And now when I measure the capacitance of two capacitors in parallel, remember these were both about 50 microfarad. Now you can see they're 100 microfarad. So the capacitance just adds up. And in the last video I showed you, when you had them in series, you could apply a higher voltage than they were rated. You can't do that with them in parallel. They actually accept whatever the source voltage is. But the capacitance does go up. As you can see, it's not 50 microfarad anymore. It's 100. Now when I measure the two inductors in parallel, now you can see we have about half of the inductance. So inductors in parallel, the inductance goes down. Inductors in series, or when they're in parallel, you get a fraction depending on how many there are. With two of them, you get about half. And then with three of them, you'll get about a third. Remember, that's the way it was with capacitors when you had them in series. Inductors in parallel, you get a fraction of their value when they're in parallel, whereas capacitors you get a fraction of the value when they're in series. And before I go, I just want to mention quickly that before I started filming this video, I was trying to measure these capacitors and I wasn't getting anything on the display. It took me a while to figure out what was wrong. What was wrong was they still had a charge on them from the video I did this morning. And so once I realized that and I shorted them out like this, these are low value capacitors with low voltages on them, so you can just short them out. Don't do that with high voltage on a capacitor or a supercapacitor. That'll pass too much current. Use a resistor to discharge it. But these smaller ones, you can just short it out. And once I did that, as you can see here, they measured just fine. And I don't think I did any damage. They only had a low voltage on them, so I'm not worried about that. But it even has the warning here, discharge capacitor before test. So just wanted to give a reminder since I just made that mistake today.